So this was the original pattern. I told it, Ariel, you have a burger. How amazing is this? I want this burger. Can somebody make this parametric burger for me? I will pay, take my card. I want this. Hello everyone, welcome back to my channel. I am Kedar, and on this channel we talk about design, architecture, generative AI and parametric design, and look at all of these disciplines through a lens of education, tutorials and installation guides. And in today's video, we will be looking at one of my favorite concepts of generative AI, that is IPAdapter. I don't know whether I like more IPAdapter or ControlNet, but these two concepts have to be my all-time favorite concepts of generative AI, and it's hard to choose between these two, but these two have to be my favorite concepts. But in essence, with IPAdapter, we can transfer style of any image onto any particular image. So like I showed in my last video, we will be transferring styles onto any patterns or anything that we have created. So we created these patterns using Rhino and Grasshopper, and then we are now able to transfer style using IPAdapter. And it is not only restricted to architecture, you can transfer any style from any design industry. Like here in this case, I'm transferring a sub onto this pattern, and you can see the cucumber and lettuce and things like that. Okay, but before we begin, I wanted to tell you where I was last week. So I was actually part of a faculty development program at CEPT University in India in collaboration with Futurely, where we were looking at all things related to generative AI, that is starting from tokens, how our image is trained, how our model is trained, and then working with ComfyUI and other tools. And while creating this workshop, I kind of came up with a unique workflow where we started with Rhino MCP, and the idea of this workflow is that we keep on rationalizing the pixels of the image, like we keep on adding more dimension to it, and this process is irrespective of architecture. You could use it in any discipline, and that's what I like about generative AI, that it is not restricted to discipline. Somebody can use this in fashion or food or anything, and you can mix match it as well. So directly you can say, no, first I want to create a 3D model, then I want to add different IPAdapter styles and things like that. So with Gen AI, it's really fun to play with these processes, and there is no one rigid pipeline. So for this workshop, we looked at Rhino MCP, then we got a vague geometry which was not really having any character, and then we used ControlNet, IPAdapter, and then added it onto Kontext, and then we kind of recomposed it using different nodes in Comfy, converted that into an image that looks like a 3D model, and then finally got a 3D model. So kind of rationalizing from what is really vague and then coming to a full process, which is what I see Gen AI doing these days. But anyway, enough about that. Let's jump to today's topic, which is called IPAdapter, or it is actually called Image Prompt Adapter. So basically what it means, where we can use text to generate images, here we can use image as well to generate images, and in simple terms, that's what IPAdapter does. And now let's look at when it actually came in existence. Okay, so the paper that talks about IPAdapter is called IPAdapter Text Compatible Image Prompt Adapter for Text to Image Diffusion Models. And this paper came in August 2023. Just to give you a little bit of comparison, the ControlNet paper had come on Feb 2023. This came almost after half an year. And here the interesting things that they say is that while we can create good images using diffusion model, it is very tricky to generate desired image using only text prompt, as it often involves complex prompt engineering. An alternative to text prompt is image prompt. As the saying goes, an image is worth 1,000 words. And that's what IPAdapter in essence does. It will allow you to use image in image generation, like adding style, transferring composition and things like that. Okay. And if you're interested, please read this paper. You will understand more about IPAdapter. But I took some of the snippets from this paper to tell you what exactly IPAdapter means. So for instance, let's say you have this image, which is now, you can imagine this as an image prompt and not just an image. You can combine these with ControlNets as well. So for example, you are combining this image with something else of a ControlNet. Maybe it's a human pose or a depth or a canny, and you will be able to transfer the style of this image onto your output image. Or for example, you want to create variations of this image, you can do that as well. Or you can say that, okay, add something to this image, and that's also possible. One thing that it really lacks is like understanding of face details. I have tried it multiple times. I think if you really want to work with humans or getting the exact face, I think Kontext is a really good model that has come up. IPAdapter doesn't really do a good job. Like you can see here as well, like they're in painting it, but like Okay, like, this is good, but not really great. But when this came in, there was no other model that was being able to do. So you have to also understand a little bit of time with Gen AI, which is getting constantly warped. Okay, and one good thing of IPAdapter is that it is not dependent on any model. So you could be using an HD model, an HDXL model, or a Flux model. IPAdapter works for that as well. Okay, so in this case, they have not mentioned Flux, but these are some of the HD or HDXL model in which they have tested the image prompt or IPAdapter, and you see we get consistent results throughout. Then going further in the paper, they are also talking about how we can use it by adding additional structural conditions, like basically adding ControlNet. So you can see these were the input images, and with the help of ControlNet, they are able to transfer the style of this original image onto their output. And you don't necessarily also need a ControlNet. Sometimes you can use just an image and prompt it to get something similar. For example, here you see this is a painting, and then they're prompting something and you get a similar output, and we'll see later on in this video how to do it. But you don't need to necessarily use another image on which you want to transfer this style. You could simply use a base image and say that, okay, make something like, okay, make a cat or something that looks similar to it, and you will get that particular output. So that's also really something powerful about IPAdapters. And apart from that, you can create variations or using prompts as well. But you will also notice that, okay, this car and this car are quite different. So maintaining that consistency is not really good with IPAdapter. I need to tell you in the beginning itself, especially with human faces or something that you want to be super consistent. In that case, we gotta use ControlNet. Also, I have noticed that when you create synthetic humans that are humans created with AI does a better job with them. Like, I have added my face in multiple models and it doesn't really do a good job. But as soon as you create an AI image of a human, because I think it understands them as really flat, then using any IPAdapter it works really well. Okay, that was a little bit of a rant about humans not being done correctly with AI, but let's see how this model actually works now. So basically in the paper, what they're saying is that image prompt adapter consists of two parts. So if you see here, it says it consists of two parts: an image encoder to extract image feature from image prompt, and adapted modules with decoupled cross attention to embed image features into the pre-trained text to image diffusion model. Did you understand? If you understand, let me know. But basically right now, let's decode this later as we go. Right now, let's focus on this particular term called image encoder. Okay. So similarly, when we use in ComfyUI, we use something called as clip text encode. There is something also called as an image encoder, where with the text encode, you convert your text into vectors. Similarly, with image encoder, you convert your image again into vector for AI to understand. Now, why do we need both of these? You might be wondering. We need both of these because the models that have been trained earlier, the checkpoint models, they understand how to create images from text. If you give them an image on their own, they will not understand. But image encoders have been only trained on images for them to convert image into a vector format. So there are two things. One is a text encoder, which understands text, and then you have image encoder, which understand images. Okay, because the models have been trained to convert text into images, not from image to image. If you want to learn how these models have been trained, I spoke about it in my previous or on earlier video. I'll link it somewhere up here. Okay, so that's what image encoder is. It is trained on a large data set of images for it to convert or give image features onto the next model. So let's understand only that much. Now let's see how these models are actually trained. Okay, so this is what they say: the overall architecture of our proposed IPAdapter with decoupled cross attention strategy. Okay, let's try to understand what that means, because I think it's really important to understand what's happening in the backend. That helps us to prompt better, So basically you have two things here. One is your prompt. For here it says a girl with sunglasses, and then there is your image. Okay, and here whatever is in blue color are kind of frozen models, and whatever is in the red are trainable modules. So that is your IPAdapter that is going to be trained. Okay, so you have your text which goes to frozen text encoder. Then you have your image that goes to a frozen image encoder. So imagine this image encoder as trained on images. This base model understand text. They're trained on images, but they understand text. You know that because you can only convert text to images. Now here what's happening is that there is no link between these two, because if I pass an image directly to a base model, it will say that I don't know what you're saying. So you can imagine IPAdapter as a bridge between these two to transfer the features of images onto the base SDXL or Flux or HD model. And that is why here you see in this process, the IPAdapter comes in between and trains. So it understands its job is only simple, act as a bridge and inject these image features onto this base model so it can take further and create an image. That's as simple as that. Okay, I have created a much simpler kind of a visual to understand how this works. So basically you have your inputs, you have your image prompt, and you have your text prompt. Now image prompt, like it said, it goes to image encoder, which is frozen. The text prompt goes to text encoder, that is also frozen. Apart from that, you have your base models that could be SD, SDXL or Flux. Always remember that they train mostly on the base models and not on the fine-tuned like realistic vision or Juggernaut models. Okay, so these three things are frozen: your image encoder, text encoder, and your base model. Now comes the part of IPAdapter, which basically, like I said, acts as a bridge and learns how to inject these image features onto the base SDXL or any other model. Okay, that's basically it. And then you get your trained IPAdapter model. Okay, and if you want to know a little bit of a detail, if you're like a nerd like me, where does it inject? You might be wondering, where is this IPAdapter injecting image feature? So it injects in something called as a UNet of the frozen model. Now what is that? So you can imagine UNet as the brain of the AI model, which basically denoises the images and gives us the image. And you might be wondering, why is it called a UNet? Because at one point it compresses the images and then it goes back and decompresses and gives us into whatever resolution image we want. That could be 1024 by 1024 or whatever the resolution of the images. So that's where the IPAdapter learns to inject the image feature through image encoder. Apart from that, they do one more thing when training IPAdapter, which is called as a decoupled inputs. So basically, couple is when they're together, decoupled is when they're separate. So images and text are separately gone into the training process. And you might be wondering, why is this necessary? So this is necessary so that both of these, which is the image and the text, get to preserve their details without interfering with each other. And prior to that, there was no separation between these. We only called it cross attention layers, but here they are saying decoupled cross attention layer, which basically means the image and the text goes in separately so that they preserve their each characteristic. I know this is a lot of jargon of words, but simply understand that IPAdapter as a bridge which kind of gives the image feature from image encoder into the base model, because the base model doesn't know what images are. They have been trained to convert text to images, and image encoder learns or knows, have been trained on what images are. So IPAdapter acts like a bridge, and that's it. But I was always wondering that, we have this recent context model that came in, and I was like, can context model do this? I kind of did comparison with context model. So here you will see this was the input image, this was the reference image. But context model didn't budge. It did not add this style on this particular image. But I was like, maybe this is only me who's trying to do this. Are actually people doing this? So actually I came across this thread on Reddit, which was like, how do I do style transfer with Flux context? Is it something that has to do with my prompt? And you can read this, and nobody's able to figure this out, like how to transfer the style or from your reference image to your input image. But if you want, you can test it out, and if you feel like you're getting results, please comment, so even I will learn something new about the context model. Okay, so in essence, you can't really do style transferring with context model. You need to go to IPAdapter for that. Okay, so I wanted to see the evolution of IPAdapters, like how is the progress of how they came from the paper to the production and now for Flux as well. So the paper, like I told you, was released in August 2023 about IPAdapter. The integration of IPAdapter in Comfy happened in September the same year. And after a year, it was introduced into Flux. And then we have the Flux Kontext this year in May 2025. So it will be almost 2 years since we have the IPAdapters, and I think we need to use it. Okay, and this I just wanted to put here the ControlNet as well, just to understand that ControlNet always came first and then IPAdapter for any particular models. Okay, now let's see what do we need to install in ComfyUI so that we can run it on a local computers or wherever you feel like running it on the cloud. So the first thing that you need to do, go to your ComfyUIs, then go to Manager on top right hand side. Then you got to go to Custom Node Manager, and here you need to install. So you might have already installed Comfy Role Studio. You might have already installed RG3 and ComfyUI ControlNet. You need to install something called as ComfyUI IPAdapter Plus, which basically gives you all the nodes that we need to work with. And apart from that, we need to install models as well. So once you install this, basically just click on it, Right now it's not saying install. Basically click on install and then restart Comfy. Then you can install models as well. So again, go back to manager, then say model manager. Then you can install all of these model which are IPAdapter. The first one is for SD model. The next two are for SDXL model. Okay, so if you type IPA, you will find other models as well. You will find something like face IP model, which is useful for faces. Doesn't really do that great. The three that I use generally are these three. If I'm using SD models, I use this one. If I'm using SDXL models, I use this one plus SDXL with H, which I have found basically the difference between the plus and without the plus is that it is more of an enhanced version and gives you better results. Okay, so we'll be using this particular model for this tutorial, and then we also need to install image encoder. Okay, so then we need to again stay in the same model manager. Then you can type something called as clip vision. So you can install this particular model, which is an image encoder, which has been, like I said, trained on images to understand and convert images into vector for then IPAdapter to take it further and inject it into the base model. Okay, and the base model that we will be using is what I use for all of my videos mostly. It's realistic vision. I use the version 4 baked VAE. Okay, now let's see what are the changes that we need to do in ComfyUI. Okay, now here what happens is that your model goes through IPAdapter and creates images. Okay, so IPAdapter falls in between basically you're pushing the model through IPAdapter and then connecting it back into the KSampler to generate image. And for IPAdapter, you input an image for which you want the style to be transferred to. And in Comfy, it looks something like this, very simple. So this is your IPAdapter model. Now here you need to add your image encoder, whatever you downloaded. You need to add your IPAdapter model and your image of which style you want to transfer. Okay, so here I have written curved residence, and now you see the style of this image has been transferred on this image, and it is as simple as that. So now let's see its use cases. So like I said, you can use it for style transfer. Okay, I had to figure out how to compose this for it to be much more readable on the YouTube format. So I'm going to move in the center. Let's see if this format works. Okay, so now here for style transferring, you see there is something called as a weight type in IPAdapter. There are multiple weight types. Generally I use style transfer or composition. Right now I've kept it to style transfer, and above that there is something called as a weight. Okay, and I wanted to use it for different prompts. So the first prompt is curved residence, then the second one is car, then there is a cat, and there is a watch. Okay, so to see that how it performs for not just architecture but for all the different kind of disciplines, let's say. So right now, after keeping weight of 1, you will see that this input image has transferred a style onto all of these images. And how cool is this? You can understand that all of these 4 images belong to one style, or they are like a output from a same family. You know, even this cat, the car, the watch, or this residence, all of these follow the style of this input image, which to me is really amazing what IPAdapter can do. And similar to ControlNet, if you reduce the weight of this number, now let's say if I make it 0.75, okay, this cat is going to come out of the screen, so please be careful. So if I reduce it, then the weight of this input image is going to reduce. Now if I make it 0.5, you will see that the weight of this input image has further reduced. So now you see this cat has a muffler. Now you see there is a hand for the watch. The residence has become much bigger. And if I make it 0.25, then you see there is hardly, like, okay, you see the green hues and tint of this particular image, but overall it's created a complete new image. So this weight as a parameter defines how much you want to influence your outcome with your input image. Okay, and if I keep it to 0, then whatever the image you get with just prompting, there's no influence of IPAdapter now. Now similar to ControlNet, IPAdapter also has a start and the end percentage, which basically means, let's say 1 is 100% of your generation. At what point you want to cut IPAdapter and then AI can take it further. Okay, so that's what it means. Or you can also say that, okay, in the beginning let AI does its job and then I will put IPAdapter, or vice versa, you know. Okay, so these are some of the tests, just changing the start and the end point. So right now I set end percentage to 0.75, and you see all of these are great. I absolutely love all of these images. Then I said let the end percent be 0.5, and you will notice that all of the composition of these images is the same because I kept the same seed value in KSampler. So that's why they all look the same. But you will see at 50% now AI is taking further, and now you see that influence of the image is reduced. If I make it 0.25, you will see the same composition of these 4, but it is very less the input image because only first 25% is taking the influence of this image and then it's totally gone. On the other hand, let's say you keep the end percent 1 and you keep, okay, this cat is staring at me. at end percent as 1 and the start percent as 0.25. So what you're telling AI now, okay, 25, the first 25% you do on your own, then you take the influence of this image and you get these outputs. Now if I say 0.25 or 0.5, the first 50% is done by AI on its own, just by prompting by the base models, and then the next 50% is through this influence of this input image. Now if I say 0.75, again you see there is hardly, the composition remains the same, but there is no real influence of the style transferring from this node. Okay, so now the next thing is I use IPAdapter for composition, and let's see how that works. So for example, in this case you have 2 rocks and a background, so it has made 2 of these residences, 2 cars, 2 cats, and watch, it didn't do it right, but it didn't do it. So basically composition means it understands what is the overall composition of the image and whatever items are there in that particular image. Let's say you have an image with 10 circles, and then you prompt say car, it will make 10 separate cars, or if you just say animals, it will create 10 separate animals for you. So it is understanding the composition of the image, but it will not transfer the style. Okay, so you have to remember when you want style transfer and when you want composition. You can also join them, we'll see that later on. Okay, so basically you need to change the weight and the weight type. So you can change the weight type to composition, and right now you see the weight is 1. If I reduce it, let's say the weight is now 0.75, and I personally like the weight to be between 0.75 to 0.9. Now you see I start to get more of the residents, the cars look nice, the cats are also looking very nice, and now we also see the watch. The one is actually a watch, the second one I don't know what it is, but it's fine. Then if I make it 0.5, now you see the composition is slightly gone away, because now it's not doing 2 things, it's only doing 1 thing. But you know, if you want, you can try that as well. Now the next thing that I sometimes use it for is something called as a strong style transfer, and like the name says, it's going to transfer the style but very strong. So here below the weight type, you can change it to something called as a strong style transfer. There are too many S's, my Lisp is trying to come up, so please be forgiving. So here you will see that with the input image and all of this output that we get, there is only the background and the rock is kind of retained. No matter you do residence or you do car or cat or a watch, the rock is retained because it's pushing it so much. Okay, you can always reduce this value, let's say with 0.75, and now you get a little bit of a better style transfer. It is very strong even so, but I generally don't use this unless I want really the influence of that image so much. But I can always go to style transfer and bump that number up. And now if I make it 0.5, you will see again it is transferring it very strong, but I really like this output, and there is so much flexibility to play with IPAdapter. I think you should really just, like, after the video, whenever you see it, just go open your ComfyUI and then do it. Okay, apart from these 3, which is your style transfer, strong style transfer, and composition, there are other weight types as well, which, to give you a disclaimer in the beginning, I don't really use it. So basically all of these other weight types, what they mean is that when they are denoising the image, how are they using the IPAdapter? Okay, so for example, linear will use this image linearly during denoise. Okay, and for all of these weight, I have kept it as 0.7 so that I don't want it to have 100% of the image transferred. But let's see what all of these different weight types do. Okay, so for linear, you get this kind of output, and you can test it out. This is just me testing it and just wanted to show you what these outputs get. I don't really use it, like I said. Then you get with this something called as ease in, which basically means that in the beginning you're telling AI whatever you want you do, then slowly take my input image into the consideration. With ease out, you are saying that okay, first you take my input image, and then you are like no, let's slowly remove the input image into consideration. Okay, so basically all of these is impacting the way the image is denoised and you get the output. Okay, so this is with ease out. Then there is something called as ease in out, which is okay, like I don't really like it. And then there is something called as reverse in out, which I really like. So what it is saying, that in the beginning you take the image, the middle part you do on your own for the AI, and in the end also you take this image into consideration. And I really like this reverse in out style, which does not transfer the style fully but also retains value. So even if you see these 4 images, you will see that okay, they might look similar, or they are in some same location, but not like they have the same style. So sometimes I also use reverse in out. Then there is something called as weak input. Then there is something called as weak output. Then there is something called as weak middle, and there is something called as strong middle. Okay, so my preferred weights, like I told you, are basically composition and style transfer. Apart from that, I rarely use strong style transfer or reverse in out. Damn, there's so many words to remember. Okay. And then the weight, I generally keep it to 0.75 to 0.90. The rest, I keep this to k plus v. Then this we will see what all of these are, and the start and the end % is left to you. Okay. There is another node which basically allows you to combine style and composition, which is also what I generally do, because let's say I also want a style from a particular image, but I want composition from a separate image. So then there is this particular node in ComfyUI, which is called IPAdapter Style and Composition SDXL, which basically means you have two image inputs, one for your style and one for your composition, and similarly you have two weights, one for your style and one for your composition. Okay, this is as simple as that. And in the ComfyUI workflow, you change the top part. So now what you do, you need to remove your old IPAdapter Plus model. You need to use IPAdapter Style and Composition SDXL, and then you just need to add two images, one for your style and one for your composition. The IPAdapter model remains the same, and the image encoder model also remains the same. Okay, and these outputs are really surprising. Let me show you some of the experiments that I have done. So for example, I wanted the style of this particular, like this Aurora Borealis kind of style, with the composition of this broken watermelon. And you see the same prompt, you see the curved architecture, how it is kind of broken this architecture into pieces. Or when you make a car, you see this like blocks of, I don't know what these are, lava blocks that are coming out. Or with the cat, again we have this discrete block that are coming from the composition of this watermelon. Again with watch as well, you have the watch, but you also have the rock. So I really like combining these two. You take a style from one image, you take a composition for one image, and boom, you get something really amazing. Okay, I also tried with another pair. So I wanted the style of this clouds, but the composition I wanted of this leaf. So you will see all of these images are firstly centrally composed, and you see this, I think it has really done well with the cat, because you get the shape of the leaf and also you get the clouds of the style. Also for this architecture, you see it's kind of taking the central composition and the clouds are also there. Okay, so this is with style plus composition. Okay, so now let's see how do we actually do this. Okay, so I have opened ComfyUI, and now let's see how to make the IPAdapter workflow. It's super simple. So I always like to start from scratch. So what I do is I go to workflow, I go to browse templates, and then I say image generation, the base workflow. Okay, now here we need to add IPAdapter in between the model and the K sampler. Okay, so double click on the canvas, you say IPAdapter advanced. Okay, and which has 6 inputs, basically your checkpoint model. So this load checkpoint goes to model, and model goes to model. Again, it's just matching the color. Then here I will say weight type as style transfer, and then we need to add the IPAdapter model. So I'm going to say IPAdapter model loader, and here you need to check which model you need. So if you downloaded all 3, I downloaded for face as well to check it didn't do a good job. Then I say plus SDXL with H, so we use this particular model. Then you need to use an image, so I'm going to say load image, and then which image do I take? Let's take this image of this water body. Okay, it's a good style to transfer. So this goes to the image. Let me move the things here. Always see to it that if this is HDXL, this also has to be HDXL. Right now this is HD. So I'm going to click on it and take the XL version of this model. So now you see XL matches XL. Amazing. And then we need to take a clip. So you type clip, and then you will say load clip vision model. And here the one that you downloaded you can select that. Okay. So I'm going to connect this here. And that's it. That's basically what the workflow is. And now you can change the width and the height of the image, because you're using an HDXL one. You can make this as 1024 by 1024. That's simple. And then you can run it. And so now you see the prompt was the base prompt, which was beautiful scenery, nature, glass bottle, landscape, purple, galaxy bottle. But it has put water inside it. And how beautiful it is, you know. Nothing else. We have not changed anything else. We have just added the image of water. Let me put this here for you to see better. And then this water has gone inside this. Amazing. Okay, let me choose a different image to see what it works with. Let's take this burger and see what happens. I really go wild with this. So please bear with me if you're like, what am I doing? Just have fun. Okay, and now you see it's put that burger inside of it. The trees look like they have meat, and there is a bun below, there's a bun on top, you know. Absolutely. You see, the cork is of bun. Really crazy. Okay, let's get a little serious. Otherwise people will be like, what nonsense am I doing on this channel? Let's take some other image. Okay, let's take this image. And then I want to create like a, let's say, traditional house in India. Yeah, let's see what we get with this. Okay, so I just prompted saying traditional house in India, and now you see how beautiful is this. Okay, so it has taken that. Okay, there has to be more. I did not put in the prompt that there has to be rocks or water body or anything. It has taken from the image itself and put the style on this particular image. So you see there is a house. Also you see there is a water, there's a reflection. You see side by side, they both look similar, and you can understand that the power of IPAdapter is so much. Okay, now after this is up to you what you prompted, and it will do it for you. Okay, for example, now this is my prompting skills. Okay, so I'm putting a simple prompt: elevation of a curved residence in the jungle with humans and trees. And now let's see what happens. Okay, I absolutely love this. I say in all my videos, but you see the influence of this image has been carry forwarded, and I wanted to also show you how much time it takes. So you see it took how many? It took like 8 seconds. That's nothing. 8 seconds is nothing. And this is for style transferring. You might be wondering why is there 16 seconds, 20 seconds. So this is when you run it for the first time. It has to load all the models. It takes a lot of time. But 8-10 seconds is absolutely nothing, And then now this is up to you. You can prompt it whatever you want. Okay. I can also now keep the same prompt and change this to composition like we saw in the presentation. Okay, now let's see what has happened. And now you see it is tried to keep the same composition of the image. Okay, there is this particular building that's come here because I said elevation of a curved residence in the jungle. It is not transferring the style, but rather is transferring the composition. So the water body comes here. I think it is taking a reference of this rock. So the building has come here and things like that. Okay. Now what else? What else do I prompt? I mean, I already showed you the possibilities of this in the presentation, but what do I prompt? I'm going to prompt something unique, like let's say pizza. Okay, let's see the output. What? This is really crazy. You see how pizza, like there are 2 pieces of pizza here because there's a huge rock here, and there's another small piece of pizza here because there is a pizza here and there's a water body. It is not transferring the style. It is just transferring the composition because you have selected composition here. And how cool is this? Okay, so the workflow remains the same. Now it's up to you whatever image you want to be the input image and whatever you want it to be the output image. Okay, and then you can always change the parameters. You can say when you want it to start, when you want it to stop, what is the weight type. So right now it was style transfer. Okay, let's see how strong style transfer works. I'm going to reduce the weight a little bit to let's say 0.8, and then let's see with pizza what happens again. Okay, let me take this image. So it is made pizza of stones. This is really cool. So now this is transferring the strong, damn it, Lisp. This is transferring strong style transfer, and we see the style being transferred to it. I've already reduced the weight to 0.8. I'm sure if I make it 1, it's going to make a stone pizza. But this is really good, and the workflow remains like this. So all you need to do is that you need to add this IPAdapter model. You need to add your clip vision, and you need to add the IPAdapter model, and boom, whatever you prompt, it will adjust it for you. Okay. So you can test it out. Now I will show you the other one, which I was talking about, composition plus style transfer. So what you can do is you can type IPAdapter, and you will see there is something called as IPAdapter style and composition SDXL. So let's take that. We don't need this anymore. Or what I can do is I can group this and bypass this, and I need to copy this base everything. Control C, Control V, unbypass it. And then the same thing, right now we need to input 2 images, one for your style and one for your composition. So let's say I put the model here, and then the model goes here. Okay. Then here again, you can decide what is the embeds, okay, that you want. This has to be K plus V, and whatever is the weight that you want. Let's keep this to like concat, which is generally what I use. Then we need these 2, which is our clip and the model for IPAdapter. Control B. So the IPAdapter goes to IPAdapter, simple color matching, nothing too complicated. And we need now 2 images. So we Control C, Control V. And then again, I will do Control V. So we need 2 images, one for the style transfer and one for your composition. Okay. So let me push this here. And then the first one is for the style that you want to transfer. And the second one is the composition. Okay. So let me select. Yeah, let's take this building. I need to do some architecture as well, right? Can't change profession quickly because of AI. That's not how things work. And then we just say, I don't know, we just say like a cubist residence made of concrete. You know, it doesn't really matter what material it is. It's going to take material from this image, but let's see what happens. And let's see the output. And you see how nice is this? So what has happened essentially, let me take this here. So it has taken the composition from here. So you see these bricks have been passed on to this particular image. So you see all of these boxes of architecture, and it has taken the style of this image. You see the mood has come from this image, but the composition has come from this image. Okay, what I can do is now, let's say I change this to burger. I don't know how this is gonna happen. And let's run this again. It's the same prompt. The prompt is cubist residence made of concrete. I don't know if cubist is a word, but whatever. So now you see the output. Now again, the blocks remain from this pattern, but now it is making blocks of burger. So you see there is onion, there is meat, there is cheese, there is bun, there is lettuce, and how beautiful is this? Okay, now what we do, we can change the prompt. Let's say just like curved apartment, and I'm bored of this. Let's keep the burger as the style. For composition, can we use this hibiscus flower? Okay, and now let's see. Okay, so this is really fun. Just play with it. You know, like don't think too much. Just play with it, play with the numbers, and you will get quick outputs. And now you see the output. Like, I don't know, it has not taken the prompt of curved apartment, but okay. First of all, it has taken hibiscus flower and it has taken burger. So now this is a hibiscus burger. I don't know what you want to call it, because looks like, okay, this is bun, there is leaves, I don't know, the meat is gone, but like this is hibiscus kind of a burger. Now if you're not getting really what you prompted it, you need to change the weight. Yes. So now you see it has taken the prompt curved apartment. It has a feel of a burger because I feel like this is bread, there are trees, but now what is lost? Our composition is lost, which means we got to crank that value. So now what we do, we keep the composition, I think to 0.9 should be fine. And let's see again what it does. Okay, I don't like this prompt curved apartment. What the hell? No, let's say curved pavilion. Apartment I have noticed as a prompt is too rigid because it has to make floor on top. Hate it. Okay, and now let's see the output. And this is really good. I know it's a little bit gimmicky, but fine. So like you see, the composition has come from this hibiscus flower, and that's how this kind of petals have been arranged. The style is of this burger. Okay, so you got to play with these numbers and also see to it that, you know, this is not that wild, like burger plus hibiscus plus pavilion. I think it's also too wild for AI to understand. Okay, so looks like it worked a bit. So I made the prompt view of a concrete residence. I changed these parameters, and now I get this output where there is this composition of the leaf and there is a style of this burger. It's not really there, but I see that these walls are a bun, so that's also fine. But the idea is that you keep mixing and you will get something really good. Okay, we have very interesting output. So the prompt is curved residence, and we have this watermelon into cubes and burger. And now you see it has, okay, I think this is a residence. It's like curved but residence, and it has taken the base of the burger. I would urge you to really experiment with this. You can always change the end weight, you can always change the end percentage, all the parameters, and see what we get. I'm not really happy yet with this. I'm gonna run it once more, and this I really like. So this looks like a residence. Okay, it has taken style from this, and it has taken composition from this. Why? Because you see all of these cubes that are arranged here inside of this residence kind of looks like it is coming from here. Okay, so you got to play with all of these parameters and you will get something really nice and amazing. Okay, so this is with style and composition. So you have one that we looked at, which is the base IP adapter, and this is with style and composition. Okay, so now that we saw a quick tutorial of how this works, and you see how simple it was just combining few of these nodes and a simple prompt, and boom, you get very good images. Now apart from that, in IPAdapter there is something called as IPAdapter Embeds, which basically allows you to combine two images to get a completely different outcome. For example, in this case, I am combining the image of falling waters with this kind of a blocky model, and then you get this kind of output. So you will see the stone texture from this falling waters has been carried forward and added here. The human figures are taken from this. The rocks from this particular image have been pushed here, and I really like this. So you might have seen some of these reels on any social media where they mix one or two superheroes, or they mix like two animals, and then that animal starts walking. So this is how you can do that. You can mix images with something called as IPAdapter Embeds. Okay, now let's see what changes we need to do to the workflow. So basically right now what was happening, or what we did earlier, the checkpoint model goes to IPAdapter model and now goes to K-sampler. Now here what happens is that you remove this earlier IPAdapter model and you add something called as a IPAdapter Embeds. Okay, and then you need to add multiple images, whatever I think max you can go till 5 images. So you can go image 1, image 2, you need to combine that, and that goes to IPAdapter Embeds. Okay, and in ComfyUI the workflow looks something like this, which is quite straightforward. You add a node called IPAdapter Embeds, then you need to add something called as IPAdapter Combine Embeds, and you see this 1, 2, 3, 4, 5. I'm right now only using 2. Then we have something called IPAdapter Encoder. So basically it needs to transfer or translate the image for IPAdapter. And same, the model remains the same. The image encoder model also remains the same. Now there are some things to be noted down in this, like IPAdapter Combine Embeds, which basically is this method of combining. Okay, so there are different ways of combining. I generally use something called as add or average or concat. Let's see what it does. Okay, so the first method is called add, which basically means it's going to blend both of these images together. So now here you see, and again, like I said, you can specify the weight of these images. So I've said weight of 1 and 1, and you get this output. Okay, so it's kind of combining the images, simple as that. Then you can say that no, I want less of this image and more of this image. So you will see that the more influence of falling waters in there in the output, and this model kind of image is very less. Or you can say no, let's make 0.5 of both of these, and this is the number that I generally use, 0.5 of this image and 0.5 of this image, so that there is an understanding of both of the images and one image does not overpower the other. For example, here you see the textures have been carry forwarded from this particular image, and kind of the design language is taken from this image with the location of the trees and the humans. Then there is something called as a subtract method, which is similar, like this was a plus b, now this is going to be a minus b. So anything that you want to remove from the first image, for example, here you will see right now this particular falling waters also has this kind of modular blocks, and this model also has modular blocks. So when I say minus this by this, you see it has converted into a sloping roof and added things like that. So it kind of is saying that okay, maybe me as a user does not want or blocky or modernist kind of building. So it kind of like no, let's, maybe the user wants me to have a sloping roof or something like that. So basically what it is trying to do, it will remove the aesthetics of image 2 from image 1. And then what I can say, okay, let's say I make this image as 0.5 and this one. Even then you see it's kind of added a sloping roof to it, and kind of understand that okay, maybe me as a designer does not want this kind of a style to this particular image. Okay, and then if I make both of these as 0.5 and 0.5, again you will see it's converted that falling waters into a sloping house and kept the texture from this image, but removed all of these cantilevers that were like this blocks of concrete and things like that. Okay, so that's with subtract. Then we have something called as concat. Now let's see what this does. Okay, so basically concat will merge both of the images while retaining the aesthetic value of both of the images. Okay, so basically what is happening here, let's see. So we have this image of falling waters plus this, so it's taken the aesthetics of this as well, and here you will see it has taken the lighting from this image, it has taken the water falling from this image. So it has a combination of both of the images. It is not neglecting any of it. Okay, for example, with addition, what happens is whoever has the higher weight kind of influences other. With concat, no matter, even if I reduce the weight of this, let's say I make it 0.5, in case of the addition you knew that this image was taking more power, but here even if I make this weight as 0.5, you will still see that it is preserving this, okay, which is preserving this particular image but taking more clues from this particular image. Okay, so you can see concat more as this visual collision between the two images rather than who has a higher weight. Okay, and then if I make both of this as 0.5 and 0.5, I love this output. Okay, I always love when things are 50% from here, 50% there. This looks so beautiful. I don't know what to say. This looks really great. And now the next one is something called as an average, which basically you can be like a plus b divided by 2. It's basically as simple as that. Okay, so here you will see that there is falling waters plus this kind of a model, and it is taken influence from both of these. So you see the slant columns now have come here, the texture has come here, the human figures and trees have come from this image. Okay, now similar to addition, if I make this 0.5, you will see that this kind of image overpowers it. So you can imagine this is 1 plus 0.5 by 2. So the weight is inevitably going to go to the image which has higher weight. Okay, and then this is with the 1 and 0.5, and then this is with 0.5 and 0.5. And just see this image, and let me tell you, this is not upscaling. We haven't upscaled any of these images. This is just combining two images, and look how beautiful it is. Look at the human figures there, look at the rocks that has been carried forward from these images, look at the trees, look at the composition, and I don't know, this is absolutely beautiful. Then the next one is something called as a norm average, which I don't really use it, and you will see why. They say that norm average means combining two images in a smooth fashion. I don't know. The only thing that I see is like it's kind of made a flat image. So again, this is with weight 1 and 1, this is with weight 1 and 0.5, and this is with weight 0.5 and 0.5. I find norm average as this very flat kind of images. If you're into that aesthetics, go for it, but like for me, this is not really doing anything. And the weird ones are these max and the next one. So from what I know, what max means is that it takes the strongest part of the images and puts it into the output. I don't know how this is translated. Maybe the strongest part, it's seeing that the color or the composition and then transferring it, but I rarely see influence of this image on this particular output. Even if I make a weight of 0.5, you will see more of this, and I think it's kind of like combining it and taking, okay, that max is more of this white color than any of these colors, and then giving it, but I find it very weird. And then the weird one again is minimum, which also I don't use, but they say similar to how max takes the strongest part of the two images, minimum takes the weakest part of the two images, and I don't know what this output is. You know, it kind of looks like a image from this old scary movies. I don't want to go to this place, but it's fine, whatever. Okay, so again, changing the weights with 0.5, change the weights with 0.5 and 0.5. And this looks good, but maybe we need to upscale it. Okay, and my preferred embeds are, like I told you, one is add, concat, and average, where add is a combination of two, which is the higher gets more. Concat, no matter what weight, it will take influence in its visual collision, and then average simply means that average of the both. Okay, and then I did some tests. I was like, okay, that was good for architecture. What can it do for other things as well? So I combined few images. So like I told you, this whatever you see on internet, they're combining animals, they're combining superheroes. Go to IPAdapter embeds and you will be the next viral person. Okay, so here I'm using concat with 0.5 and 0.5. So I'm combining the image of a cat with an eagle. And look how nice, how amazing is this? Then I'm combining this kind of a chocolate swirl with a croissant, and then you get this. And this is my favorite. I didn't think this to happen, so I took image of waterways and with this Indian sweet, and look how beautiful it looks. I just went ahead and kind of animated it, and I love it. I absolutely love it. I find these, hallucinations, so you call this weirdness with AI, amazing. Okay, and then this one is with architecture, because like, okay, I come from architecture background, I need to use something. So I combined this like floral or flower image with the same base model, and then I got this, which is really nice. Then I combined the image, Taj Mahal image with the clouds, and I was like, I want to see what it does when I make a video of it. So I make a video rotating it, and I think this is really nice. I want to imagine a place or a building which has clouds as a backdrop of that building and see what it looks like. And then I combine this simple like image which has like rays coming, and then with a mood board, and you will see all of these pieces have been attached to this particular image. Then I was like, oh, let's go a little bit wild and see what happens. So I combined this image of this crackling or cracking concrete with ice cream, and you see now how nice is this? The ice cream is cracked, but the flavors are retained. And this is really amazing. I just combined the image of this leaf with this smoke. Again, like I said, concat 0.5, 0.5. And look how beautiful it looks. I really like it, and I went and animated it. And you see how nice. Like, I don't know what to say. Okay. And then I was like, let's combine these robot with a burger, and I have a robotic burger, This is really fun to play with. Just go to image embeds, IPAdapter embeds, combine two images, use either average, add, or concat, give 50% value, and you will really get nice images. Okay, and I was first introduced to this last year during October or something, when like I saw the peak of combining animals, and I was like, I need to do this. I need to combine architecture. So I started combining architecture. These are all again using image embeds only. So the first one is with combining Taj Mahal. On the other side, it's combining Villa Savoy, and you see it retains the architectural characteristics of the first image and imports it onto other. I don't really remember now whether I had used add or concat. And the video, I think I used Luma AI for it. So I used the start frame and the end frame, and then I get this particular outcome. Right now there are a lot of other video generation tools. maybe I need to make a video on video generation. Okay, and you get this nice looking, really great images. And what I really like about image embeds is that if you take real images, it will carry forward that style and create realistic images. Like, so these were taken from Wikipedia because they were taken by somebody on site. So you see the output also doesn't look like hybrid. It does look like hybrid, but it looks like, oh, this might exist somewhere. And that's what I really like about image embeds. So you can just try take an image of your pet with the leaf, and you see it gives you, like, you will feel like this cat or this leaf exists somewhere. Okay, I'm gonna stop blabbering and you can see the video. Or maybe I should put music, no? Okay, let me add some music in between. Okay, and then the next one was, then I was like, okay, why only combine building with building? That's not really great. So then I was like, let's combine leaf with buildings, or this Plumeria alba flower with again buildings, and then you get these kind of outputs, which really look great. It kind of you're imagining something that doesn't exist, but also makes you feel like, oh no, this could exist somewhere. And that's the power of IPAdapter. Now let's see how to do this, which is basically IPAdapter embeds. Okay, so now that you looked at image or IPAdapter embeds, let's see how that is done. And that is also super simple. Okay, so I made this two workflows, right? I'm going to copy this, Control-C, Control-V. Okay, let me unbypass it. Okay, and now we need to use something called as IPAdapter embeds, which is this particular node. Okay, and now here we again have 6 inputs. One is a model, so straight away model goes to model, and then model goes again to model. Okay, then we have IPAdapter, so we need the same models basically. So I'm going to copy those, so we connect it here. To bypass or unbypass, if I hope you remember, it's Control-B. Okay, and then we need embeds, so I'm going to type embed. First we need to combine the embeds. This, like I said, has 5 embeds, so you can add 5 images in together. So right now the embeds goes to positive embeds. Okay, and here, like I told you, the method generally like I said, I use add or concat or average. And now we need to use this embeds, so we need to use something called as IPAdapter encoder. We need 2 of these because I'm only going to use 2 images. I'm going to say Control-C, Control-V for the second one, and the second one goes to the second one. And now here we need to input 2 images, and here we don't need to prompt, so I'm going to remove the prompt and just keep dot. So you see the prompt is just a dot and nothing else. And then the second image, what about we use a burger? Okay, this is getting a little wild, but yeah. And then we connect the image to image. Okay, and now these two also need your IPAdapter model and the clip model. Okay, so this goes here, this goes here. So many nodes. I wish we didn't have to use so many nodes, but like, as long as it's not rocket science, I think I'm okay with it. Just connecting colors to colors, and anybody can. I mean, most of us. I mean, unless if somebody's colorblind, I don't know. Okay, sorry. I took it for granted that everybody can see color, and I don't think it's a good way of looking at things, considering the circumstances that we live in. And let's keep the weight as I like to keep it as 0.5 and 0.5. Super simple, nothing too complicated, no prompts needed. And this is their image embeds. So you have your IPAdapter embed. This you can keep it to whatever you want, the weight, the style, whatever is it, fine. And here we need to keep it K plus V. I think it's better if I keep it to style transfer. And now let's see what output we get. Oops, I think we need to keep this to linear now because it is just transferring the style, as you see. I don't know why it's made a female. Damn, the bias of AI. But let's keep it to linear and then let's see what happens. Okay, and let's see. And now looks like, okay, we get Taj Mahal model, but we don't get the burger effect of it. So let's see, let's crank up some values. So I'm gonna make this to addition. I think that should be good. And now let's see what we get. much better. Still not there yet. The one that I show you in the presentations have been done 4 or 5 passes. So I've never combined burger and Taj Mahal. So I need to figure out that what is the value that will work better. So I'm just gonna change some values and see what happens. Okay, let me add more of burger. So let's say the burger weight is 0.5, 0.75, and the Taj Mahal weight is 0.5. And now let's see what happens. And now you see we get more of the burger and less of Taj Mahal. But now we know that, okay, burger has to be reduced a little bit. So you need to play only two numbers here. That's the game. There is no needing of adding any prompt. So now I'm going to say burger as 0.65. I think 0.75 was too much. And Taj Mahal is same as 0.5. And now let's see what happens. Okay, and now this is super cool. There is more of Taj Mahal, but also burger. I love it. I don't know am I allowed to do this, but you can mix anything. And the good part is no prompting. Absolute zero prompting. Gone, prompting is not needed. And now you see, okay, this is the Taj Mahal. Okay, and now there's a bun on top. And I think this is like colors from onion. And there's, I think there's like onion ring and things like that. Let's say something else. I don't want to fixate on creating a burger Taj Mahal. Let me combine a rhino. This one, the dancing house. Let's combine this and see what we get. Right now, okay, I want more of house. So house is a point. The dancing house is 0.65. Rhino is 0.5. And let's see what happens. Okay, like this, I've never explored this. So there might be something that comes up very goofy. So like, please don't judge me. What? I love it. I love it. You see, the house, let me take this image here. Yes, you see the structure of this house is retained because we gave it more value. But now it has kind of added eyes. It has added the horn of rhino. This is beautiful. And you don't have to, like I said, this is, I don't know, I feel like a child combining images, and it gives you a hybrid image of two. And what you got to do, you only got to change these two numbers. You can keep it to add or concat or average, and don't need to prompt. Just like keep on iterating, and let's see how much time it took. So it took around 20, 30, 40 seconds. It's less than a minute. Okay, I know, like I have a good graphic card, but still I don't think it's going to take more than a minute. So you know, like keep on playing, keep on experimenting. Let's do one more. Okay, let's combine the Sydney Opera House. This looks nice with this kind of a light coming through a room, and the box is kept. And I want to keep both of them 0.5. Okay, and then let's see what we get. And this will be my last expedition. Okay, and I love it. I love it. This is so good. Sydney Opera House is more like a ship, but the rays are coming from top, and this is really good. You know, this reminds me of the old GAN models, generative adversarial networks, that we used to play before with AI. I don't know, in 2017 or 18, I had worked with AI, which used to give this mashup of buildings, and you could hardly recognize it. This image looks like this, which is really, really good. But anyway, you can combine anything. Combine whatever you want, and then be the next star of combining with IPAdapters. Okay, and now let's move on to the next topic. Now let's see the favorite part of me, which is IPAdapter plus ControlNet. Okay, those all what we looked earlier is good for like creating scenes, creating kind of clips in between. But if you really want to have exact precision of what input you do, you will still need help of ControlNet, and you can combine that with IPAdapter as well. So basically, the patterns that I had created earlier, I used ControlNet, and you see what kind of outputs I get. With ControlNet, it's really using the pattern but not adding anything. So the prompt was elevation of a residence with a gradation of windows surrounded by humans and trees, and I don't really see the humans and trees. And I used ControlNet Canny and Sketch, and I reduced these values to 0.6 and 0.2, and now you see I get some kind of a human here, but this doesn't look like a architectural building. So here you really need to use IPAdapter, otherwise you're not going to get really good result. So then I added this particular image of IPAdapter with weight 1, and I love this. I'm sorry if I'm screaming in your ear, but I love this. You see that there is a white space in between, and now what AI is doing is that, okay, there is white space, maybe we can add these kind of terraces in between. But this really is like pushing the boundaries of AI and saying that, okay, take something from me and I will take something from you, rather than like blindly accepting what it gives. And I hate doing that. Okay, then I took this next image. I was like, okay, this was the input, and then I took this robots image, and you see how nicely it is transferred. The prompt was different this time. The prompt was view of a curved building made of robotic parts with humans and trees, and you see how nice it is. I can imagine this could be in some movie, like a sci-fi movie. Brilliant. And then this last one, I'm really enjoying combining food with this patterns. It looks really great. I never thought of it. Okay, I just said aerial view of a masala dosa. Masala dosa is like a savory dish in India, and here you see this is the input image, and you will see how amazing it has put curry leaves in the pattern of this, I don't think you can do this in reality. Nobody's going to eat so many curry leaves, but still to be able to visualize this just by an image of a masala dosa and this pattern is really amazing. Like it's so powerful. Like I can't explain. Like I feel like I wish I could do something with it. It's like, okay, sorry for my enthusiasm. Then let's see what workflow changes we need to do. Okay, so right now we have this already we see this workflow where checkpoint model goes through IPAdapter and then we have an input image. Now to the same workflow, what we need to do, we need to add ControlNet because ControlNet goes through prompts. So we need to use the input image that we want to change with the IPAdapter and we add ControlNet. Okay, and the workflow totally looks like this. It looks really scary, but don't be scared. It's very simple. It's the same workflow. The middle part is your base workflow. So you have your checkpoint models and you have your prompts and you have case sampler. The bottom one is your ControlNet. So you can add your ControlNet stack. It could be canny plus depth or sketch or anything. And the top part is the IPAdapter. Okay, it's very simple. It looks real, like so many wires, but it's super simple. Okay, and now let's see how to do that as well. Okay, we goofed up a lot in this video, but now let's come to a little bit of serious working. AI is not all fun and games. AI is a little bit serious as well. Okay, so I'm going to take the base IPAdapter workflow. So now here everything remains the same. I want to keep it to style transfer and that should be okay. And now we need to add your control nets. Okay, so which we already know. So I'm going to do it again. If you have not seen the earlier video, right now we know we don't need this image resolution because the control net, we get image resolution from the control net. So let me load that image. Okay, so I have loaded one image. Now this will be where, like the pixels or the size of this resolution will come in. So we got to encode this. So the image becomes the encode. I'm just going to go very quickly because we already saw this in the ControlNet video. Don't want to bore people who are like, he keeps doing more of this and then wasting time and then just want to make YouTube watch hours. Okay, so I'm going to try to be as fast as possible. Okay, so I've quickly arranged this, which we have already seen. So this base one is your ControlNet, okay, and the top one is your IPAdapter, and then the rest of the part is your old original workflow. Okay, so now you can add whatever pattern you want. You could add your whatever control nets you want. I'm using the canny and the depth, and then you need to use the comfy role, which will allow you to stack control nets on top of each other, and then you have the same thing that we did in the earlier. If you want, I can always link again here the ControlNet video. So I have that kind of a puncher. So generally, whenever you have or want to transfer the style, it's better that something that correlates works. For example, okay, I'm going to get this pattern. And now here you need to describe what the prompting is important here. You need to describe what it is. So I'm going to say, so I've just said elevation of a lamp made of bricks with light coming through the lamp. Okay, and now let's see what happens. I don't really know if this weights and all that are going to work. But right now, let's see if it works or no. Okay, so I'm going to run this quickly. It's going to take some time. Okay, so as you see, the pattern is transferred and we are using the reference image. So this image, let me take this here. So we are getting the style transferred. We're also getting the pattern, but it's not doing great. Why is this happening? Okay, so you got to understand that whenever you're transferring any style, because you see it is fully packed, it's going to also do things around it. So it's always better if you can match, let's say, a lamp to an image of a lamp, an architecture to an image of an architecture. Sometimes there will be anomalies, like you can match pattern to a dosa, but not always. It's not going to work always. Let's try this watermelon. I think this should work well because there is some space around it and the prompt remains the same. Okay, so let's try with this watermelon example and let's run this again. Now let's see the output. So this was the input with the watermelon example and it does well. It does really well. Now you see that especially at the boundary there is no pattern and then internally there is pattern. Now we need to change some more things. Always keep changing. Okay, let's keep it to there and let's rerun it. So you're never going to get anything 100% correct at the first go. Whatever I show you again in the presentation, there have been tries that I do multiple times. So you got to try with multiple factors or multiple numbers, and then once you will get it and you'll be like, boom. Interesting. Maybe I need to make a video on the fails of generative AI because nobody talks about it. Okay, you might hear a small fan noise. That's my laptop making noise because it's like, okay, it's too much for this video. Come on, man, like shut me off. Okay. But now let's see, and now you see this looks much better, right? We have the pattern, we have the kind of color from the watermelon. It's also kept on a table, and now you got to keep tweaking it. Okay, ideally what I prefer is that you take an image of this and you take an image of a lamp as well. So that makes it better. I don't have an image of a lamp, but maybe I can show you something that is, I have an image of a So let me take an image of this falling waters. Okay, and now let me take an image of the pattern something else. Okay, so I've taken this pattern and I've taken this. So I wanted to have like an architecture thing. So I'm gonna say suggested view of a curved residence made of concrete in jungle with humans and waterfall. Okay, basic prompt. You can always keep on tweaking the prompts. And now let's run this and let's see the output. And wow. Okay, I have like, this is really wow. Okay, so this was the input image with falling waters. And now you see how it has done those balconies. Okay, we are not upscaling it, so that's fine. But this is really good. This is really good. And there is waterfall and things like that. Yes, falling waters has come on top of it. But what I can do now, I can say that, okay, let the weight be 0.8. So we got to reduce the weight so that less of falling waters comes on it. But now you see, because this was an architecture kind of view and this is also an architectural view, this does a much better job. Okay, so that's what I keep saying, that whenever you're using this, try to see that the top and the bottom image follow the same kind of industry. Let's say you make an image of a car, let's have an IP adapter of a car. If you make like a bag, have an IP adapter of a bag, and things like that. Let's like link them together. Okay, let's see this. I have a feeling this is going to be good. Yes, how beautiful it is. You see, it is carried away the pattern, this carry forward the pattern, taking from falling water. There is falling water here, and those materials, it's in the jungle. I don't know why it is made those wall on the either side, but you get the idea of it. You can change these parameters and you get a better output. Now if I keep doing it, I'm going to get freezed up by my computer. But one last, we gotta do that food one. And now here I want to say aerial view of a burger, and this is going to be the last one, guys. I really pushed this my computer. Okay, let's see the output. I think this is going to be great. Let me slide on top of it. So this was the original pattern. I told it aerial view of a burger. How amazing is this? I want this burger. Can somebody make this parametric burger for me? I will pay, take my card. I want this. Okay, let us see this. So it has added buns on the either side. It has added meat wherever the black pattern is. It has curved the cheese in this plane, in this form. It has added onion. There is some kind of sauce. Do you think I should go in food AI images? This is really good. Okay. So, try it, explore it, and you will be blown away with whatever IPAdapter can do. But this is really the power of IPAdapter is when you combine it with something else on its own. Yes, if you want like let's say consistent catalog, you want to make of product design, product photography, brilliant. Please use IPAdapter. This will blow your mind. Like, okay, I'm getting hungry right now. I've been recording for a long time. Okay, there's some more things to be covered. I'm going to shift back to the presentation, and that will be the end of this video. And how amazing was that? You just combine some pattern with some images and you get really good outcome, And I think that is the power of IPAdapter. It personally has helped me push my imagination. Like, it has taught me that, oh, you don't need to limit to the field of architecture. Take something from fashion, take something from food, take something from photography, take something from car design. And with no matter what tool you use or no matter what node you use, there are always going to be some do's and don'ts. And I like to think of this whenever I'm working with. So the first do is that see that the input image is clear. Okay, don't use a blurry image, because if you use something that's blurry, the output is going to be blurry or it will be like a lower resolution pixeled image. So don't do that. Then match the IPAdapter model to the base model. So if you're using an HD IPAdapter, use an HD model. Simple. If you use a Flux one, use the Flux one. Simple. Then the next one is always keep tweaking the numbers. So I keep telling this that what numbers I use, don't necessarily use that. I'm only giving you base reference. Always to whatever images you have, change to your own numbers, because what numbers I use might not be the numbers that you want. Okay. And don't crank up the weight too high. I would always say that the limit is 1.2. Don't go more, otherwise you will see blurry things. Okay. And for more control, always combine it with ControlNets, which is like amazing to use. And then don't use it for faces. If you want to really work with your own face, I think Kontext is really great, which you saw in the earlier videos. It does really good job. And then use different IPAdapter variants for different tasks. Okay, don't get caught up in like using only one part of IPAdapter. Sometimes use embeds, sometimes use style, sometimes use composition. See how things can combine. Okay, but don't get too carried away and stack all of these on top of each other, because then the AI gets confused and doesn't really know what to do of what. Okay, so these are some of the do's and don'ts that you need to remember. But similarly, how we have do's and don'ts with any model, we also have limitations that we are going to come across. And in the research paper, they mention one such limitation, which is like it cannot synthesize images that are highly consistent with the subject of a given image. Okay, so that is why it doesn't really do great with faces or things like that. I have tried it. Okay, so I added one of my faces and I was like, can you put this? So the prompt was a man in a car, and then you see who is this, like, okay, I can see visually there are clues of my face, but it's not really me. Okay, if you want, like I said, with faces, really go with the context model and not with the IPAdapter. Okay, do I have how many fingers? 1 2 3 4 5 6. Damn, and see, I have 6 fingers. Okay, and apart from faces, I don't know if it's really a limitations, but if you want to have control, you need to use ControlNet. Like, there's no other way about it. So you need to use ControlNet. For example, I gave this image and I told IPAdapter make a building of like so many floors and use this kind of a reference image, and you see the output doesn't really correlate with the input image. So you need to use ControlNet if you want to have more precision. Okay, and that's mostly it. I know this video is going to be one of the longest video that I have done, but I wanted to cover IPAdapter in its full essence and not give in bits and pieces. And if you work or make something, always feel free to share on social media. You can always tag me as well, so don't hesitate to tag me. I'm always happy to see what people make when I teach them, so you can always tag me and I'll be happy to see what you have made. Okay, so I hope you like this video. Thank you for your time. Please use IPAdapters, and also please like, share and subscribe, and I will see you in the next one. Thank you.